Okay, let's revisit our parallel lines. We'll call this line S and line W, and it's being cut by transversal G. Alright, so the problem might tell you somewhere, it should, that line S is parallel to line W, and that G is a transversal, line G is a transversal. So it'll say G is a transversal. And they may give you an angle measurement. Let me give you this one to be 70 degrees here. It's the measurement of that angle. And then they might ask to find all the other angles. So right away, because line S, this is a line, you know that this upper piece has to add up to be 180 degrees. So this piece must be 110 degrees, because 70 and 110 add up to be 180. As soon as you put that 110, you would automatically know that this one right here, now look at this line, G, 110 and 70 add up to be 180 degrees. We already knew that this one should be 70 because these two angles were corresponding angles and they're equal to each other. This one right here, two ways you want to do it, really three ways. If you take this side, it's going to be 70 plus 110. Right? 70 plus 110 equals that 180 degrees. Or if you took this 70 plus 110. So even from doing it this way, 70 plus 110. Or look at this. This is 110. This one has to be 110 because they're vertical angles from each other. If you remember, we talked about corresponding angles and alternate interior, alternate exterior. What you'll find is the alternate interior angles will be equal to each other. So see, this almost forms like a Z. And trace this. This 110 and this angle are equal to each other. 110 and 110. They are alternate interior angles. That also means that the other ones are equal to each other. Alternate interior. And as soon as you put them on, you know that vertically, this one must be 70, and vertically this way, this must be 110 degrees. So you could fill out this whole entire like parallel lines and cut by transversal diagram with all the angle measurements just given one of the angles.